May 30th, 1964. The Indianapolis 500 turns to chaos. Fire engulfs the track. 2 drivers lie dead. Ford's revolutionary engine, a secret project years in the making, teeters on the brink of disaster. But how did a British chassis, an Italian carburetor, and a renegade Ford engineer spark this tragedy and ultimate triumph? The truth? Detroit's greatest racing engine was born from betrayal, blood, and a feud that nearly destroyed Ford Motor Company. By 1962, Indy car racing was a museum. The Offenhauser Offie engine, a 1920s relic, had won 15 straight Indy 500s. Its creator, Fred Offenhauser, ruled like a mob boss. Teams feared innovation. But one man saw weakness. Don Frey, Ford's Maverick VP. His plan? Build an engine so radical it'd humiliate Offie or get him fired. Gentlemen, we're not just building an engine. We're starting a revolution. Frey's weapon? A secret skunkworks team. Bill Gay, Ford's advanced engines chief, Mauro Forghieri, consultant, and Phil Remington, Shelby Cobra genius. A weight-obsessed engineer. Their mission? Shrink a Fairlane V8 to 255 cubic inches, add dual overhead cams, and make it scream to 8,000 RPM. Insiders called it Project Suicide. While the Indy 500 has seen some of the wildest and most innovative American race cars ever built, it was also one of the least creative races in the world. By the 1960s, one particular engine had completely taken over the race category. This engine was the Meyer-Drake Offenhauser engine. Originally designed back in the 1920s, this engine had won every Indianapolis 500 since 1947. From 1950 to 1962, across 13 races and 429 possible qualifying spots, Offenhauser engines powered 416 of them. Sure, there were a few exceptions. The odd Novi, a Cummins diesel that grabbed pole position in 1952, and even a Ferrari that showed up that same year. But make no mistake, this was an Offenhauser-dominated empire. It was also a roadster race. Even though talented builders put their own spin on the cars, the basic shape and setup of an Indy Roadster stayed pretty much the same. Outside of a few daring experiments, everyone stuck to the same formula. And it would stay that way until someone forced it to change. Born in New York, Dan Gurney was the race driver who, in the early 1960s, got the attention of Ford and helped spark a revolution. In early 1962, Gurney won the Daytona Continental, the race that would later become the famous 24 Hours of Daytona. That win connected him with key people in the racing world, and it didn't take long for Gurney's growing reputation to land him an Indy 500 ride. The call came from Mickey Thompson, a legend in hot rodding and racing innovation. Thompson had a car designed by John Crosthwaite, a tube-frame chassis, engine behind the driver, and powered by a Buick V8. Thompson believed that with the Indy 500's displacement rules, the lighter Buick engine could be a real advantage, and weirdly enough, he was almost right. Gurney qualified 8th and ran solidly in the top 10 all day, until a transmission failure forced him out early. His first Indy 500 ended in disappointment. But something much bigger was happening behind the scenes. You see, Gurney wasn't alone that day. He had invited a man who would change everything, Colin Chapman. Chapman, the brilliant mastermind behind Lotus, was famous for designing lightweight, simple, and brutally fast cars. At first, the Indy 500 didn't mean much to him. It was just an American race. But Gurney, always a smart connector, convinced Chapman to fly out, even offering to pay for his trip. Once Chapman saw the race with his own eyes, he was hooked. On the flight from Indianapolis to the Monaco Grand Prix right after the event, Chapman couldn't stop talking about it. He saw exactly what Gurney saw, a wide-open opportunity to win with smarter design, not just brute force. and Chapman wasn't the only outsider paying attention. Walking around the garages during that 1962 race was a man named Don Frey. Most fans wouldn't have recognized him, but Frey was the general manager of Ford's car division and one of the most powerful men at the company. As Frey looked over the field, he saw almost nothing but Offenhauser engines and one lonely Buick. To him, it screamed opportunity. Ford needed to be in championship car racing, and specifically, at the Indy 500. On race day, Frey bumped into Hot Rod Magazine's Ray Brock, a sharp, well-connected journalist. Brock casually asked if Ford planned to get involved at Indy. Frey's answer was, "Next year, we plan to race one, maybe more cars here." No one at Ford even knew about that plan yet, including most of the executives back in Dearborn. But Frey meant it. When he returned to Michigan, he started rallying engineers and top brass to support his vision. By July, he organized a secret meeting with Dan Gurney and Colin Chapman. In front of a room full of skeptical Ford engineers and executives, Chapman laid out a plan with his trademark confidence. Some in the room scoffed. Others flat out rejected the idea. After all, when you've done something the same way for decades, even the smartest people can struggle to see a better way. Chapman's idea was beautifully simple. Build a very lightweight car, use a small, light Ford V8, making around 350 horsepower, make fewer pit stops than the heavy roadsters, and eventually crush the competition with speed, efficiency, and smart design. To Chapman, the heavy, clunky Indy roadsters looked like tractors. In his mind, Ford wouldn't just win, they would dominate. Among the men at that meeting was Bill Gay, Ford's executive engineer for the company's advanced engine section. After listening to Chapman, Gay decided to see for himself whether this British guy's bold claims held any truth. Bill attended a few races following the Indy 500 and quickly saw exactly what Chapman had observed. Championship car racing at that time was suffering from engineering stagnation. It was a revelation for someone like Gay, who had never really studied the scene. After what he witnessed, Gay bought into the project completely. Once he was on board, the resources of the Ford Motor Company were fully committed, and the project moved forward in earnest. Ford recruited principal design engineer Bill Gay, Mauro Forghieri, and Phil Remington, who focused specifically on managing the weight of the engine they would develop. They began developing the engine in-house, which is unusual in itself. Meanwhile, Colin Chapman's company, Lotus, would be responsible for designing and building the chassis, while Ford handled the power plant. We called it the double cross. It crossed Offie, crossed tradition, and crossed our fingers it wouldn't blow up. As radical-looking as the Ford DOHC Indy was, it was actually based on a standard Ford production engine, the 221 cubic inch, the smallest, lightest, and most compact engine of its time. In the Ford Fairlane, it made around 150 horsepower. A hotter, expanded 260 cubic inch version powered the first AC Cobras, cranking out a strong 260 horsepower. Since Ford was targeting a 255 cubic inch displacement for Indy, the small block V8 was the perfect starting point. Phase 0 began with a stock 260 cubic inch Cobra engine, producing around 260 horsepower. Phase 1 focused on squeezing maximum horsepower from a pushrod setup and benchmarking it against the dominant Offenhauser engines. Ford didn't just guess. They bought a genuine Offie, tuned it with the help of experienced Indy racers, and strapped it to their dyno. At first, it made 378 horsepower at 6,000 RPM. After fine-tuning, 401 horsepower. They also talked to winning drivers like Roger Ward and teamed up with legendary chassis builder A.J. Watson to study his roadsters up close. Ford left no stone unturned, meticulously mapping every bump, dip, and contour of the speedway itself. During testing, they uncovered a critical insight. Engines with high-torque camshafts between 250 and 270 degrees of duration performed better than those chasing only peak horsepower. High-torque engines accelerated harder out of corners, leading to faster lap times, even if they gave up a few miles per hour at the top end. This changed everything. By the end of Phase 1, Ford's internal report gave the green light to Phase 2, developing an all-aluminum 255 cubic inch V8. The first aluminum blocks and heads weren't perfect, but they were good enough for brutal dyno testing. The iron-sleeved block weighed just 72 pounds, and each cylinder head was a featherweight 16 pounds. It was a promising start to Ford's bold assault on the greatest American race. By the Phase 2 deadline of November 1st, 1962, factory engineers had a running engine on their hands. Durability testing was ready to begin, but there was a problem with the carburetors. After crunching the numbers, Bill Gay and his team realized the 46mm Webers were too small. They were costing them power and might choke the engine. They needed bigger carbs, but Weber didn't make anything larger, and they weren't interested in starting either. Bill Gay wasn't taking no for an answer. He hopped onto a flight to Italy, determined to talk to Weber's chief engineer in person. Due to a kind act he had shown to the engineer in the past, Gay was given a listening ear, and Weber agreed to build special and fast 58mm carburetors. Back home, the new carbs were fitted. The engine roared to life on the dyno, hammering out 460 horsepower at 6,800 RPM. Durability testing pushed it even harder. 24 hours straight at full throttle. And it passed. It wasn't just reliable, it was a monster. The next big test was at Daytona on January 22, 1963. Act 2. Lotus, Lies, and Italian Carbs. Enter Colin Chapman, Lotus's cunning founder. He promised Ford a featherweight chassis but hid a brutal clause. Engine failures are Ford's problem. Meanwhile, Ford's carburetor supplier, Weber, backed out. Engineer Bill Gay flew to Italy, smoked some cigars with a factory manager, and smuggled out 58mm prototypes. But the engine had a flaw. The valves danced like rattlesnakes. We lost 3 engines in a week. Chapman wanted out. It was like riding a rocket that might detonate. But when it worked, God, you could feel the future. A 6-day tire test with Goodyear, Firestone, and the brand new Lotus 29 race car. Ford engineers worked day and night, switching engines between 2 Lotus cars. Each engine saw 14 to 16 hours of punishing track time, and they held up beautifully. But there was a ticking time bomb: valve spring harmonics. At certain RPMs, the springs vibrated dangerously, risking engine failure. One of the Daytona test engines lost a valve during a post-run inspection. If that had happened at Indy, it would have been catastrophic. Back at Ford's High Performance and Special Models Operations building, the team scrambled. They needed a new solution fast. As a result, they launched the Phase 3 of the Indy engine program just weeks before the Indy 500. Fast forward to the qualifying day, the Lotus Ford showed up at the Brickyard and shocked everyone. Low-slung, mid-engine, and European style with an American hammer under the hood. The Lotus Ford qualified second. It was faster, lighter, and more efficient than anything else on the track. On the race day, the Lotus cars ran strong, but tradition fought back hard. The Lotus cars needed fewer pit stops, but pit crews weren't ready for the new strategy. Fumbles in the pits cost them precious time. In the end, Jim Clark and the Lotus Ford finished second. A stunning result. But it wasn't the win they wanted. Still, the message was clear. The rear-engine revolution had begun. IndyCar would never be the same again, and Ford's Indy V8 had proven it could take on the world. The 1964 V8 engine. In 1964, the Ford Motor Company faced a critical choice: evolve or be left behind on the racetrack. Ford's little pushrod V8, cranking out 375 horsepower and 360 pound-feet of torque, had already been pushed to its absolute limits. At just 360 pounds, it was a marvel but not enough for the future Ford envisioned. On May 7th, 1964, A.J. Scussel of Ford presented a bold new plan to the Society of Automotive Engineers. Ford wasn't just going to tweak the old engine, they were going to reinvent it. The target was a screaming 8,000 RPM. At that level, a traditional pushrod engine was simply out of the question. It was time for something completely different. A dual overhead camshaft V8. The first Phase 1 engines kept the old 1963 block, crank, rods, bearings, water pump, oil pan, and gear drive. But on top was a brand new 4-valve per cylinder DOHC head with pent-roof combustion chambers. First run was nearly untuned as it generates 400 horsepower at 8,000 RPM. But there were problems. The exhaust valves ran too hot, thanks to the initial chamber design. And worse, the ignition timing went haywire because the camshafts twisted at high RPM, scattering the spark. The engineers had to revise the combustion chambers for better cooling and move the ignition drive from the back of the camshafts to the front, keeping spark timing razor sharp. Ford hoped Weber would come along for the ride again in 1964, but Weber refused. They'd done enough in '63 and weren't interested in designing new carburetors for one engine, so Ford switched to a Hilborn mechanical fuel injection system. Low pressure, constant flow, simple, and brutally effective. One of the wildest features of the final engine wasn't even planned. Originally, the exhaust ports were underneath the intake ports the traditional way. But once engineers tried fitting the engine into a race car chassis, disaster. The exhaust had to run straight through the suspension, which is a no-go. The solution they settled on was to flip it and move the exhaust ports above the intake. This not only solved the packaging nightmare, but gave the intake runners a straighter, more efficient shot at the valves, boosting airflow and horsepower even further. Another interesting detail of this 1964 engine version is the block. Ford used the same pushrod block, even kept the cam tunnel. How'd they pull that off, right? They inserted a tube where the camshaft would normally go. This tube acted like a diffuser for oil drainback, and even helped vent the crankcase. It also stopped oil from pouring onto the crank and turning into foam. The cylinder heads used 1.4 6-inch diameter valves, 4 of them per cylinder. The camshaft had a point, 440 lift, 306 degrees of duration, and a tight 87 degrees of valve overlap. That's seriously aggressive. The cam followers were bought straight from Meyer-Drake, the same ones used in the Offenhauser engines. The valve springs ran 360 pounds of pressure when open and 95 pounds on the seat when closed. These heads were crazy advanced for the time. As cast, the combustion chambers were within 3/16 of an inch of final specs. Thanks to the pent-roof design, traditional machining wouldn't cut it. They finished them with electrical discharge machining, EDM. In 1964, this was basically science fiction. Magazines called it a miracle of the modern age. No other race car on Earth had cylinder heads finished like this, and few even today. Phase 2 engines were built and tested to fine-tune ignition, heads, and fuel systems. At one point, some engines had 3 spark plugs per cylinder. Turns out the extra plugs added complexity with barely any power gain. So they settled on 1 plug per cylinder. Now to one of the most visually amazing parts of this engine, which is the exhaust. After a ton of testing, they settled on 71.6-inch pipes, although 36-inch and 18-inch systems were developed for other chassis. The final engine weight was 406 pounds, just 6 pounds over the original goal of 400. At Phase 3, this beast, properly tuned on gasoline, generated 425 horsepower at 8,000 RPM and 295 pound-feet of torque at 6,400 RPM. Tragedy and betrayal. By 1964, Ford's double cross was ready. Bobby Marshman hit 190 miles per hour in testing, but at Indy, Eddie Sachs's car erupted in flames. Chapman blamed Ford. Jim Clark, Ford's star driver, quit. Yet hidden in the wreckage was a clue: Marshman's engine unscathed. Ford's engineers discovered the truth. Dunlop tires, not their engine, caused the crash. Chapman kept his job. But Ford's revenge was coming. The truth was yet to be revealed. Fast forward to January 20th, 1964. Bobby Marshman tested the Phase 3 engine at the Ford facility in Kingman, Arizona. Marshman achieved speeds of up to 190 miles per hour with the new engine in his race car, marking the first successful run of the Phase 3 engine. During this phase, the engine was refined, addressing the previously identified issues with the Indianapolis dyno and testing different exhaust systems. By February, durability tests were in full swing. Arizona's harsh conditions provided the perfect environment to stress test the engine's endurance. In March, the team returned to Indianapolis. These tests would determine if the Phase 3 engine had what it took to dominate the Indy 500. A top speed of 153.8 miles per hour was recorded, and the cars were hitting 183 miles per hour on the straights. The performance was impressive, both on the track and in terms of engine refinement. In April, Ford returned to Arizona for final testing. Fuel injection systems, maintenance checks, and wear tests were the focus, ensuring that the engine was fully ready for the rigors of racing. Then came the 1964 Indy 500, a race that would end in tragedy. 7 Ford-powered cars entered the race, including the likes of Eddie Sachs, Bobby Marshman, and Jim Clark. A devastating crash took the lives of Eddie Sachs and Dave McDonald, halting the race for over an hour. But the worst was yet to come. Bobby Marshman was in the lead, 90 seconds ahead, with his sights set on lapping A.J. Foyt. But an unfortunate mistake, going too low on the apron, damaged the transmission plug, causing oil to leak. Marshman was forced to retire from the race. That left Roger Ward as Ford's last hope. Despite poor pit stops, Ward managed to finish second, 1 minute and 24.35 seconds, behind A.J. Foyt, who went on to win the race. Ford executives were not pleased with the result. Lee Iacocca, a key executive at Ford, demanded a full investigation into the failure and even called for Colin Chapman's firing due to his insistence on Dunlop tires. Jimmy Clark swore off ever returning to the Indy 500, but somehow Chapman retained his job by invoking a contract clause that allowed him to keep his cars. He continued to run them at USAC races for the rest of the season. Despite the setback, Ford's commitment to the project did not waver. Executives flew to England to offer Chapman a deal for 1965 that significantly reduced his budget and his power within the team. But it came with the condition that Clark would return for one more run at the Indy 500. By 1965, Ford's dual overhead cam V8 program had evolved into a full-fledged race engine business. Louis Meyer, the legendary figure behind the Meyer-Drake-Offenhauser engine, was hired to manage Ford's engine sales and service. Meyer set up shop in Indianapolis, where he sold engines to a growing number of customers. At the 1965 Indy 500, Ford Power dominated the field. With 68 entries in the race, 45 cars had their engines in the rear, and 24 of those were powered by Ford. However, there was an issue. Most Indianapolis mechanics had little experience with an engine as intricate as the Ford dual overhead cam V8. To solve this problem, Ford forbade anyone except their own team from working on the engines and made sure only their mechanics tuned the race cars. When the race started, Ford showed its dominance. Jimmy Clark, starting from pole position, led 190 of the 200 laps. The only time he was not in the lead was when he came into the pits for a stop, and A.J. Foyt stayed out. Clark's victory was a coronation, leading the race from lap 1 to 65, and then, again, from lap 75 to 200. The pit crew, led by the legendary NASCAR Wood brothers, executed lightning-fast stops, with the first one completed in less than 20 seconds. Ford's engines performed flawlessly, with only 3 failures among the 20 Ford-powered cars in the race. The failures that did occur were due to issues like nitromethane use, transaxle problems, and clutch failures. Clark's victory, which was the first by a foreign driver since 1920, showed Ford's commitment to racing excellence. By 1965, Ford had taken a beefed-up passenger car engine, evolved it into a race-winning powerhouse, and completely reshaped the competitive landscape in IndyCar racing. Within just 2 years, the Ford dual overhead cam engine had captured the hearts of racing teams, with more than 20 engines on the grid at the 1965 Indy 500. Ford's dominance would continue, making the 1965 Indy 500 an iconic moment in motorsport history. The Ford dual overhead cam engine became a legend after it helped win the Indy 500 in 1965, 1966, 1967, 1969, 1970, 1971, and finally in 1977. These wins showed how powerful and reliable the engine was, making it one of the most successful in the history of the race. Chapman said, "It was smooth, like a turbine. You could feel the engineering." In the early 1970s, Ford decided to hand over the entire engine program to A.J. Foyt, one of the biggest names in racing. The engine was rebranded as the Foy V8, marking the start of a new chapter for both Ford and Foyt in racing. In a surprising move, drag racer Jim Busby took 2 of the Foy V8 engines and put them in a dragster chassis. He raced the car in a National Hot Rod Association (NHRA) event, where it won a trophy for Best Engineered Car. After the event, Busby sold the engines to an IndyCar team, making a good profit. Have you ever wondered how such a seemingly impossible project, filled with obstacles and tragedies, evolved into one of the most successful engines in racing history? 1965. Jim Clark returns. Ford's engines, now nicknamed the Phoenix, dominate. Clark leads 190 laps. Offie is dead. But what if Sachs's crash had ended Ford's gamble? Comment below. Would Ford have won without Sachs's sacrifice? Was Chapman a hero or a villain? This is Paul from Rare Car Stories. Catch you next time.